10.6 is about circles and arcs. Let's talk about the main parts of circles. P is the center. Okay, we have AB is the diameter. And this is nothing new for you guys. You know this, most of this. P is the center of the circle. And PC would be our radius. When we start talking about angles, if it has the center in it, so angle APC would be what we call a central angle. Okay, and then when we're talking about arcs, let's take like arc BC, we would consider to be a minor arc. And let's take arc BAC would be considered a major arc. So if we're naming the arcs here, our minor arcs, again, minor arcs by definition are less than 180 degrees. Major arcs are greater than 180 degrees. And semicircles, so let's do this, less than 180 degrees, greater than 180 degrees, and semicircles equal 180 degrees. Okay, so if the arc is less than 180 degrees, it's called what we call a minor arc. So if we look at the circle here, what are our minor arcs? Well, arc AD is one. It's less than half a circle. Arc CE is another one. Those are the easy ones. Arc AC and arc DE are all minor arcs. Semicircles, what's the half of the circle? Well, arc AC or DAC, sorry, is one. Arc DEC is one. Now the other half, arc ACE is one, and arc ADE is one. Those are all my semicircles. And my major arcs, which are greater than 180 degrees, and these get tricky at times, arc ACD. And remember, arc ACD, which is over there, is the same thing as DCA. Those are the same arcs. You don't need to list both of them. Arc CEA, arc EDC, I'm sorry, EDA. I was right, EDC. Looking at the wrong circle. And arc DAE are all my major arcs. Problem 2, the thing we need to remember is when you have central angles, the arc measure, or the measure of the arc, not the length of the arc, the measure of the arc, equals your central angle. And you can use the fact that obviously circles are 360 degrees to get that. Well, if we're looking at arc BC, okay, BC is right here. What is the central angle that matches it? Well, 32 degrees matches it, so BC is also 32 degrees. That's the measure of the arc. Okay? BD is this one. Well, that's BC plus CD, which gives me 32 plus 58, which would be 90 degrees. ABC is over here. Looks like ABC is what we call a semicircle, automatically 180 degrees. And AB, well, that's 180 minus the BC, which is 32 degrees, which gives me 148 degrees. When you're trying to find the length of arcs, now the measure was it's equals your central angle. The length of the arc, how far it is from A to B, you take the measurement of angle A, of arc AB, divided by 360 times 2 pi r, times your circumference, or pi d. Okay, so either one, it doesn't matter. Here, understand the concept is you're trying to find out, when you take the measure of AB divided by 360, you're trying to find out what portion of the circle that is, and then you multiply it by circumference, and that gives you your angle. So we look at problem 4. We want to find the arc length of all these things. Well, the length of xy, well, what's the measure of the angle? The measure of the angle there, the central angle, is 90 degrees. So I'm going to take 90 over 360 and multiply that by 2 pi r or pi d. So in this case, pi times 16, or 16 pi. Punch in your calculator and simplify. You end up with 4 pi as that distance. Leave it in terms of pi is fine. Let's look for length xpy. Xpy is this major arc here. Again, we have this 240 degrees right there, so that's the measure. So 240 divided by 360 is the portion of the circle I'm talking about. I want to multiply it by the total circumference. Well, the radius is 15, so it's 2 pi r, so 30 pi, or 2 times 15. Okay? Punch that in my calculator, I end up with 20 pi as the length of that arc.